Thank you. It's great to be here. Thank you for the invitation to speak. As has been mentioned, my name is Matt Bates. I work for a company called Venafi. I've been involved in the cloud-native ecosystem now for probably the best part of 8 years. So I co-founded a company called JetStack, which some of you may know, and we've worked a lot in the open source. We contributed a project called Cert Manager, which provides the automation of TLS certificates in Kubernetes. So yeah, it's been a pleasure to see the development of cloud native. And what I'm going to speak to you today about is zero trust. We all hear a lot about zero trust. But really what I want to specifically talk about is zero trust for machines. Physical machines, but increasingly software machines. Software is eating the world. We need to think about how we can apply zero trust principles to software, particularly in a cloud native world. So I'm going to really talk about identity. And I think this will hopefully set up Zach and his colleague. They'll be talking about the paper that they've written, 800-204. So the zero trust story is much more than I think is commonly told. When we hear about zero trust, we quite often think about human access, user access to IT systems. And I think we're all in varying degrees of maturity around adoption of zero trust. But really what we're now seeing is an explosion in the number of applications that are being built by developers. It's easier than ever to build software, which is a great thing. But of course it means that we now, from a security perspective, have to be able to deal with all of that. So really what I want to talk to you today about is how we need to be able to think about zero trust in the context of a cloud native world, where we're building applications fast and we're building them for the cloud to take advantage of the cloud. And I really want to talk to you about sort of how we think about identity from a software machine perspective. So it's really I'm going to do over the next 25 minutes. So obviously, we're all very familiar with the principles of zero trust and the reasons for it. The perimeter that we're all very used to now has absolutely changed. No longer are we going into the same office using the same device and logging into systems that typically would have resided within the data center. That perimeter has gone, and we now live in an increasingly mobile world. 4G, 5G, near ubiquitous. We can pretty much work from absolutely anywhere. And it's now very familiar for all of us to use zero trust in a lot of the technologies we use to do our everyday lives. So Google, in their wisdom, brought out a paper that we're probably all very familiar with, which is Beyond Corp in about 2014. And this is really, there's been a number of implementations, and of course this has inspired a lot of zero trust software and also models as well. So this is kind of effectively the zero trust that we all know, and I should expect you'd all be nodding your head saying this is something that we're familiar with. As I said, this is really where we are, though. The perimeter no longer exists in quite the way it used to be. No longer can we assume that everything within the walls of our data center is blessed. In fact, we have to assume really that everything in our networks is effectively hostile. So we really need to be able to change the way we think about this. And we do so by changing it. So rather than the perimeter now being effectively physical, so certainly virtual in the case of networks, we actually have to think about identity. And we do so, of course, using zero trust models, by thinking about effectively the user. Not only kind of who I am, but I have to have a means of being able to authenticate who I am using multiple factors, using the context, if you like, of the request that I make to the system. But really the focus has very, very much been on people and remote access. How I as an employee can access systems, corporate systems, contractors, third parties. Really the focus is very much, and a lot of the discourse around zero trust is around people and remote access. But really the future, when you think about it, is machines. Underlying all of these IT systems are machines in all manner of forms, physical but increasingly software-based machines. And so people, we can measure those, of course, in the billions, but machines are increasing exponentially. You can credibly measure this in trillions. The physical devices that we have in our pockets, but also all of the software that underlies all of these systems. And we'll look at the various different forms of that as well. Of course, you can't get away from the fact that, in the last 6 to 12 months, we've just seen a step change in AI. It has accelerated incredibly fast. I'm sure we've all seen this, unless we've been under a rock and haven't noticed this. there's been huge changes, and they've really kind of effectively been quite democratized. So now we can sort of use bots like ChatGPT, Google's Bard, and a lot of the work that's also going on in the open. But underlying all of this, though, is effectively a set of machines. Machines which are doing the learning, machines which are serving the models and providing us with the assistance. And so we have an explosion. And if we think, we've seen it, we haven't really seen anything yet with the rise of AI. So machine identity is a coin that was effectively termed by the company that I work for, Venafi, and it's since been recognized by Gartner. So really, how do you define machine identities? Well, it can be sort of in the form of physical devices. So smartphones, tablets, IoT devices, which of course, in our homes, in industrial applications, desktop computers and servers and so on and so forth. But increasingly, like with software eating the world, it's actually all of the various different forms of compute that make up machines. So that is everything from virtual machines to containers, now to even kind of more like serverless workloads as well. And that's, of course, increasingly where developers are. They're not thinking so much about deploying code to physical machines, assembly code to machines. They're now thinking about using much more higher level languages. And so they're using technologies like containers, like serverless frameworks to be able to do that. And that's obviously then manifests itself on physical machines. So machine identities, you may also be referred to as service identities, workload identities, non-person entities, non-human entities. Effectively, we're talking about very much the same thing here. So this is the sort of the picture that we have. This is like the modern picture that I'm sure is very familiar to most of you. Certainly with the customers that we deal with, this is the picture that they are dealing with. It's highly heterogeneous now. No longer are we thinking about putting those workloads solely into the data center. No, we're now thinking about putting it into cloud environments with all the cloud transformations that are going on, but not just like single cloud environments, multiple cloud providers. And increasingly, we're looking to use things like SaaS as well, so services which are managed for us, perhaps, which may reside in different clouds. So we've got this kind of like sea of complexity to deal with. And all the while, we have machines being spawned pretty much all the time. There's also just been this vast increase in the number of developers and the productivity of developers as well. This is, today it's so much easier to get started. There's huge amounts of education, support. There's open source tooling that Ed was talking about. Open source has just made it a whole lot easier to get started. And we have the advantage of cloud, SaaS, APIs, that mean that you can consume things very, very rapidly and start building applications, which of course is a great thing. However, it kind of creates complexity, effectively. We can now create software faster than ever before. We can deploy it faster than before. And what we now face is a situation with our, thinking from a security perspective of how to actually understand what's out there, have visibility of this, have control, and have all the governance that's required to make sure this is a secure environment for these applications to operate. And so this, I think, sort of encapsulates this pretty well. This is a network visualization of the, I believe, 1,500 plus microservices that power a digital bank in the UK called Monzo. It's a UK challenger bank. They've now got, I believe, over 2 million customers. But they built a bank from effectively the ground up, and they used modern cloud-native ways to do that. So I think now they're up to about 2,000 microservices. But you can still see the nature of the complexity here. We've made it easier to build software. It's more modular. It's more granular than before. But we have to really think carefully about the ways in which we secure that. And I would have actually note, and I've kind of included the link there, there's some great work that they're doing around being able to think about security, some really innovative solutions that they've employed around some of the microservice platforms that they've built. So the question is, for a world beyond people and human access, what zero trust model can we employ? How do we take zero trust principles and apply it to this sort of machine world? And I note here zero implicit trust, because often I see zero trust. And actually what we really mean, of course, is zero implicit trust. And perhaps the implicit is implicit here, but I think it's worth noting. So fast forward to 2019, and some of you may be aware that Google put out a paper called Beyond Prod. So this is sort of like the iteration, next iteration beyond Corp. Specifically, what they addressed here is how to employ security in a cloud-native world. So using and building on all of the technologies that they've, of course, for some part open-sourced, if you think about what they did with Kubernetes, from the work they did with Borg. But they put it a piece of paper, and what they did is they took, and I'm going to take an extract from Beyond Corp and apply it to this machine kind of world, effectively this cloud-native world. So now no longer can we assume that the perimeter of the data center, we can no longer assume that everything is safe within the data center effectively, just like we would with the corporate networks and the human access that we've been familiar with. We are with Zero Trust so far. So rather now what we need to be able to assume is that all of the microservices that are operating within the data center, all of the applications, the network, just because it's flinging packets around does not mean it's trusted, does not mean it's secure. So we have to be able to employ security within the confines of the data center. This is incredibly important now, not least because the data center is sprawling, right? It's not a single physical location, but actually it can reside across multiple cloud environments, cloud providers. So what they promote effectively is rather than kind of assuming the physical location, the network perimeter, that's kind of moved away, and rather than think about traditional controls like firewalls, ACLs and such, we need to be able to think about effectively the context and the characteristics of the machine itself, much like we would with human access. So rather than relying on a single form of authentication, we now need to look at multiple forms of authentication and the context of the request and the characteristics of the request. And specifically, they talk about code provenance, so understanding where the code comes from, whether it's signed and verified throughout the entire supply chain. It has service identity, machine identity. We'll speak more about this, and trusted hardware. I won't talk about all of the aspects of Beyond Prod, but if you're interested, the paper is, of course, open, and I'd highly recommend you take a read of it. So really what I want to look at is this sort of the before and after picture. So if we think about sort of the establishment of trust and trust zones, the traditional way of doing this has been to create sort of network perimeters effectively. And to use the likes of things like network segmentation. So we're all very familiar using firewalls, myriads of firewalls and ACLs to be able to do access control. But the fact is that this is just really kind of infeasible to be able to do at scale, not least with cloud workloads, those that are very highly ephemeral. We saw in Ed's presentation how a vast majority of containers are actually very, very short-lived. So no longer can we rely on being able to do that in a kind of very fixed way. We actually need to be able to look at being able to give services very unique identity and to be able to establish service-to-service authentication and authorization. So you might think in terms of identity, well, we have IP addresses, we have host names. Isn't that enough? Well, it is not enough, particularly in sort of these highly dynamic and ephemeral environments. IPs, of course, are very virtual. When networks, packets travel through cloud-native environments, they're typically passing through proxies, they're typically passing through load balancers, and all manner of network transformations take place. So we cannot rely on the IP address. It's also, as I said, it's very short-lived. So containers come up with an IP, and very shortly they will come up with something very, very different. So it's no longer the case that we can use what has traditionally been very useful for doing access control. So now we need to be able to think about making it much, much more finer-grained, and we need to go to effectively to the workload level. So the container that's spawned in a cluster needs to have its own unique cryptographic identity, and we need to sort of effectively decouple it, if you like, from the systems that we're very used to using today. Compute, as I said, is traditionally been very fixed. If you were to deploy a server, it typically have a very fixed IP address, perhaps have a fixed location. In this kind of world of Kubernetes where you have container orchestration, then you're using sort of bin packing techniques. Workloads can move around. They are highly dynamic. They are elastic and they scale. And so you can't really rely on where they are. So no longer can we rely on sort of the location of where something is. We can't rely on the IP address. So we actually have to think about having rooted identity and root of trust. In terms of controls, in terms of authorization, so once you've thought about being able to identify workloads, how do you then sort of authorize requests which are made to those systems? Well, it's been traditionally the case that you would embed a lot of that authorization logic into the application code. And I've seen all manner of applications where that's been the case. Developers have actually written authorization logic and they put it into their code. They may well have used libraries to help them, but for the most part, a lot of it's very, very kind of custom and bespoke. And this is like very error prone, and it also really doesn't scale. It also means it's also quite tightly coupled as well. So it means that if you want to make changes to the authorization logic, you want to make changes to the way that the service can be called by other services in a cluster, you actually have to be able to redeploy the actual whole application itself. So Beyond Prod promotes almost like this decoupling and giving effectively the platform the capability to do this using the identity that's been provided to the workload. So you effectively now can have policy that lives as code. It can be committed to code repositories. It can be reviewed. It can be audited. And you can have that actually applied throughout the network, and we'll talk a little bit more about this. So identity is kind of absolutely foundational. A famous philosopher once said, an entity without an identity cannot exist because it would be nothing. And so really machine identity effectively becomes core to this. As I said, we are now in a world with multi-cloud and cloud native where workloads can strictly run anywhere. They change fast, they're highly dynamic, and this is all operating at machine speed. So how do we address this problem of identity for machines? Well, you might say, well, there's ways to do this already, right? We can use all manner of different secrets. We can use things like usernames, passwords, APIs, bearer tokens. We can go and use some PKI to do this. But the problem that we often face with almost all of these are secrets, and they are, of course, precious, and they need to be protected. And the way to do that, is to be able to put them quite often into things like secret stores or the vaults. The problem with that approach, of course, is that we then have to have another secret, and effectively you have this kind of turtles all the way down problem. The introduction of secret zero, effectively, is an incredible challenge. So, fortunately, there's been a lot of prior art in this space already, kind of addressing that bottom turtle, so to speak, and developing identity systems specifically for machines. And so, very, very briefly, just kind of touching upon some of them, in the early 2000s, the Plan 9 operating system actually had a way to be able to address this with a per-user agent that it developed, which would enable you to store your credentials, but it would also sort of actually do the job of establishing secure communications on your behalf with other applications and services. Fast forward to some of the work that Google did in 2010 with LOAS, so this is the low overhead authentication system. They, needed to have workload for each and every one of their microservices and developed an identity system that would be able to issue identity automatically. So as a workload was born in their Borg clusters, they would actually be able to mint an identity and have that automatically rotated. And that enabled them to secure RPCs across their vast networks between services. And they also developed an interesting kind of wire protocol, LTS, as well. Netflix did some work in 2014 to be able to use cloud providers to be able to help effectively sort of attest to the identity of compute using kind of instance metadata. So it was a kind of a real step change. And then obviously the work that Google did with Beyond Corp, Beyond Prod. But really what I want to focus on in the last, 6 minutes, is a project called Spiffy. And it has an runtime implementation called Spire. So in 2016, Spiffy was born, sort of co-founded by one of the original creators of the Kubernetes project, Joe Beda. It actually took a number of these sort of big tech companies, Netflix, Google, and co., and sort of really brought them together, because having built a lot of these systems, learning from the lessons of having built these systems, to be able to come up with a set of standards for really how to do this. And so, if you now fast forward to 2022, this Spiffy project has now graduated in the Cloud Native Computing Foundation, and it actually underpins a lot of other CNCF projects. So you'll hear a little bit about Istio today, it actually is implemented in part in Istio as well. Now, I could probably talk for probably another 20 or 30 minutes about some of the aspects of Spiffy, but I really just want to sort of look at it just at a high level, and hopefully it's enough to spark some interest, and you can go away and find out a little bit more about it. I'm, of course, around to ask any questions. But Spiffy, secure production identity framework for everyone, effectively a suite of like APIs and a specification for being able to do production identity, machine identity, in heterogeneous environments. This is all about the issuance, this is all about the management of those identities at scale, and importantly, across different environments. So this is not specific to cloud native. This can be employed in sort of more traditional environments as well. And so there are different aspects of it. I'm going to kind of drill in on some of these just so we can understand a little bit more about it, and I'm going to kind of illustrate how it works as well. So firstly, we have the Spiffy ID. This is a way of being able to effectively kind of uniquely identify a workload. We'll take a look at an example of this shortly. With a workload API is a way of being able to obtain identity, so a way for an application to be able to ask for its identity. But what's really unique about this is that it does so without having a pre-shared secret. So rather than actually having to, having that bottom turtle kind of problem where you've got to have an additional secret, effectively, it does so without having to do that, and we'll look at how it does that. We also have the SVID, so this is actually a way of representing the identity in an actual identity document. So there's the Spiffy verifiable identity document. And this is a way of actually manifesting, actually creating some kind of cryptographic asset that you go and use, the application can go and use to establish a mutual TLS connection. And there's also ways and means to be able to federate, so to be able to share trust roots between different trust boundaries. So if you're wanting to establish a relationship, a secure relationship between different clusters, as an example, you'd be able to do so using its federation capabilities. So just going to take a sort of closer look at how sort of this works in the last few minutes. So this is an example of how the workload is able to obtain its identity. And it does so using, and I think this is a very unique aspect of Spire, it does so using a number of different plugins which are able to provide effectively attestations, proofs that the workload is valid. And so it does so in this particular case, and there's a couple of examples, by introspecting the Linux kernel. So it can actually inspect the processes which are running, and it can compare that to what has been known and has been pre-registered effectively. So there is a prerequisite here to pre-register a workload with a set of metadata, and then at the point of runtime, when the identity has been requested, that's the point at which these attestations are applied. There's also attestations and plugins for the Kubernetes API. So, of course, if somebody has made a request to run a workload, all of that state exists in the Kubernetes API. The agent here, in conjunction with the server, can actually consult the API and kind of verify whether that workload should be running, and indeed whether it should be running in the way that it's presented. You can also use things like the container runtime as well. But I think what's important to note is this is all without having to provide a secret. And it's issued, it's rotated, and it's fetched kind of on demand, effectively. So no longer is it kind of the responsibility of the developer to have to kind of concern themselves with having to do this. They can use the system to do it for them. And indeed, in fact, in some environments, like, for instance, the Istio mesh, a lot of this actually can be done on behalf of the developer altogether. So it's relatively transparent. This is an example of what a Spiffy ID looks like. Effectively, it encodes obviously the protocol in the form of a URI here. We've got the trust domain, and we've got a set of text that we can use, a string that can identify uniquely the workload. So in this example, I've got the MySQL database that's within the payment system. But it's kind of up to you how you effectively do this. And as I said, there are two different SVIDs. There's more work on some additional formats, but at the moment you can encode this service identity into an X509 certificate. This gets put into a DNS SAN, or you can also use a JWT as well. So what you now have is this ability, if you think about this across a heterogeneous environment, so you've got Kubernetes clusters, you've got on-premise virtual machines, and you've got kind of serverless workloads as well. You've now got this ability for workloads to be able to obtain identity at runtime. They do not have to have any pre-shared secrets. You have an ability to attest this. It's consistent. It's cryptographically verifiable. And it's something that now applications can use throughout their different environments. And so if you're using the likes of Istio, Istio will in fact do this for you. So if you were to peel back, look under the hood effectively, you will see that a Spiffy ID is actually given to each and every one of the workloads. And the proxy uses that identity document on behalf of the application itself. So this is, gives you the capability of this in heterogeneous environments. You now have, with this identity, kind of this foundation, the ability to sort of apply authorization logic over the very top. And so you can do this, at the point of the ingress gateway. You can do this at the point of the sidecar proxies, which kind of coexist with the workloads. Or indeed, you can do this in the egress as well. But you now have a means of being able to use that identity and have assurance that identity has been granted, effectively. So I think I'm really out of time. So I'm just going to move to kind of summarize really kind of where we are now. So the past we've been thinking about really kind of IP and network security being the perimeter. That is now no longer the case. We need to think about bringing identity to the workloads themselves. Workloads are typically very now short-lived, and the identities that they're granted are also short-lived. So, in terms of things like revocation, things are now more passively revocated. Rather than trusting everything, we can move to a per identity model. So this is really where I think we are going, and it's great to see some open source technology embracing and supporting a lot of this, a lot of these models too. So as I said, the zero trust model is a lot more than commonly told. It goes beyond humans. It goes beyond access, human access. It's increasingly cloud native. We have to look to be able to provide machine identity and have workload protections around that. Thank you very much. Yeah, I think we, if anyone's got any questions, I'm more than happy to take them at the break. So come find me. There's also a lot of people from the Spiffy project, which is fantastic. So I've spotted a few different faces. I think I've spotted one just now, who will, if I can't answer, will certainly know the answer. So yeah, please come and find us. Really happy to help. And yeah, I'll take you during the break, I think. Yeah, thanks. Yeah, it's great. Yeah, that'd be great. Yeah, I think. Thank you. Thank you, everyone. Thank you.